This question, the first thing is, like, if you were trying to take the derivative, you would be rewriting the radical. So with integration, we're going to want to do the same thing. We're going to want to rewrite the radical. So we're going to start off by writing that square root as a 1/2 power. So this will become x to the 5th and then x to the 6th plus 4 to the 1/2 power dx. Okay, now in terms of your integration, once you rewrite the radical, then you ask yourself, and this is kind of the process you go through, is you say, okay, is there a flat out rule that tells us that integral? And there isn't. So then you go to the second step that says that you can simplify. And in this case, I mean, you've simplified as much as you can with this 1/2 rewrite. And so the third method leaves us with u substitution. Now, you really do kind of know that you need u substitution here because you see parentheses. So anytime you see parentheses, you're really thinking about choosing that quantity for your u. So what we're going to do is we're going to go through u substitution because our other two methods failed us here, and we will pick as our u that quantity in parentheses. So that will be the x to the 6th plus 4. Okay, and we'll leave the 1/2 out of it because we don't want to start trying to take a derivative of parentheses to the 1/2. All right, now our du, so remember that with derivatives you drop, and then with antiderivatives you add. So what's going to happen here for our du is we're going to drop terms down because we're taking the derivative. So this 6 drops down, and then we have x to the 5th, and then the plus 4 is a standalone constant, so that drops to 0. And then we still have the dx. All right, so this becomes our little key to life here for how we are going to transform this integral in terms of u. So the first thing I do is focus on replacing the u. So this x to the 6 plus 4, all of that is going to get replaced with u. So this integral will now look like x to the 5th, u to the 1/2, and then dx. Okay, so that's our u replacement made. Now we go to our du replacement. So for du, I need a 6, and I don't have a 6. So what I'm going to do is I'm going to multiply in by a 6. That, of course, changes the integral. So I will divide by 6, and then that balances it out. So now I have the 6, I have the x to the 5th, and the dx. So those three factors, the 6, the x to the 5th, and the dx, all of those will become our du, by definition of what du is equal to. Okay, so all of that is being replaced with du, and then we still have our u to the 1/2, and we still have our integral sign, and we still have the 1/6. All right, so at this point, we look at this, and our integral is completely in terms of u. So now we are ready to integrate. And to integrate, we're just going to use our power rule. And our power rule for integrals says that we add 1 to the exponent, and then we divide by the new exponent. Okay, so if I'm adding 1 to 1/2, that plus 1 will change into a 2 over 2, so I will get 3/2. So this will be 1/6. Now when I integrate, when I do this add 1 to the exponent, I lose the integral sign in the du. So I'm looking at u to the 3/2, and then divided by that new exponent. Now you could immediately go to flipping the denominator, or you could just write the 3/2 as you want it, and then because we do not have bounds, we'll write the plus c. Okay, now before you go to the next step of plugging back in the u, you do need to, of course, simplify this 3/2. So we talked about this in class, but when you have a fraction in the denominator, what you are going to do is you are going to flip that fraction. So what will happen is the 3/2 is now going to become 2/3, u to the 3/2. You still have the 1/6, and you still have the plus c. All right, so with fractions, remember, you multiply straight across. So you could say that the 2 and the 6 cancel, or you could say it's 2 over 18 and then reduce to 1/9. It really is all up to you what you want to do there. So this 2 and 6 reduce to give you a 3 in the denominator, and that leaves you with 1/9, and then u to the 3/2 plus c. So that is our simplification of the integral. And now what we're going to do for our third and final step is we're going to substitute back what u is equal to. So our u definition was that u is equal to x to the 6 plus 4. So that's what we're going to plug in for u. So this u, because it's two terms, will need parentheses around it, will get replaced with x to the 6 plus 4 to the 3/2 times the 1/9 plus c. Now, you can write it in that formulation. Again, a lot of it kind of depends on what the answer key has, but of course you could also write this if you wanted to as x to the 6 plus 4 to the 3/2 all over 9 plus c, and that would be fine as well.